All right, here's the parent function for tangent. First thing we look at is we look at our a value. Our a value is 1. It's not called the amplitude when you talk about the tangent function. It's called amplitude with sine and cosine because that's how high and how low the graph oscillates. This one, the leading coefficient is 1, and so that's only going to change tangent of pi fourths. Tangent of pi fourths will be 1. It's just called a vertical stretch and a vertical shrink. Okay? Our period is still pi because the number in front of x is 1, so pi divided by 1 is pi. So this graph is going to repeat itself every pi radians. There is nothing else inside here, so our two starting vertical asymptotes are going to be at a negative pi halves and a positive pi halves. So that's what I'm going to start with, those two asymptotes. I have a negative pi halves and I have a positive pi halves. And then I'm going to repeat this pattern every pi radians. So I can fit 4 vertical asymptotes on this graph. Following finding your vertical asymptotes, you want to go through and you want to find the points within each one of these. And it's going to repeat itself, okay? So, nothing being added, subtracted, multiplied. Tangent of 0 is 0. Tangent of pi fourths is 1. Tangent of negative pi fourths is negative 1. And if you want to get really technical on this first one, the tangent of 3/8 pi, this would be 3/8. This is 4/8, so 3/8 is up at about 2.4. So this graph comes up here, and then at negative 3 pi eighths, this would be at about a negative 2.4. And so this graph does not have an inflection point like the cubic does. It does not flatten out. It does in fact go at about a 45-degree angle. So for those of you that have been drawing this like this, this is what the tangent function looks like. And once you get one branch, you can go through and you can then repeat within these other intervals. And repeat that same pattern. So there's my tangent function. Range is all real numbers because it's going up and down forever. Domain would be all real numbers except, and we would write it as, you can use words, you can write it with symbols, but writing it as I did in my example earlier on the handout, we would say x is all real numbers except x cannot equal pi halves plus n times pi, where n is an integer. And this will give you all of your places where your vertical asymptotes exist. And this would be your domain, and then your range is just all real numbers.